Hello, geometry. Welcome to our first attempt at a flipped classroom. We're looking at 8.1, which is the Pythagorean theorem and its converse. You should have your note sheet in front of you. If you do not, you will need a piece of paper so that you can take notes and be ready for class tomorrow. Alrighty, let's start. So we're going to start with the Pythagorean theorem. We all know what it is already. It deals with a right triangle. The side opposite your right angle is your hypotenuse. The formula is c squared plus a squared equals b squared, which can also be written as a squared plus b squared equals c squared. So either way. We want to find the length of the hypotenuse in a right triangle. We're solving for x. We all know how to do this. X squared equals 7 squared plus 24 squared. So x squared is going to equal 49 plus 576. So x squared equals 625. In order to get x by itself, we use the inverse operation, which is to take the square root. So x is equal to the square root of 625. Lucky for us, if we put that in our calculator, it is an actual perfect square of 25. At any point, if you need to pause the program to finish your notes, you may do so and then push play again and off you go. Let's take a look at another one. We have a board that rests under a doorknob. It's a creepy day in the neighborhood. We want to lock our door shut. That board is 6 feet long and it drops about 5 feet from the base of the door, creating a right triangle. We want to find how high up that doorknob is. Again, we look for our hypotenuse, which is 6 squared equals 5 squared, which is one of the legs, plus the square of the other leg. And we use our algebra skills to determine what x is. So x squared is equal to the square of 11. Eleven is a prime, so we know we are done. In context, you can always put an approximate in there using your calculator. What's the square root of 11? And it's approximately 3.3 feet. Okay. So in context, if you're using a contexted application problem, you are allowed to round and give an approximate. Otherwise, leave your answer and exact answers, which is leaving it as a form of radical. All right, you should pause the video now and try the next two problems. When you've got them completed, then go ahead and turn your video back on and we will go from there. Okay, in the practice problems, those are the answers. You should have found x is equal to 29, x is 4 rad 21, and x is approximately 3.6 feet long. If you were not able to get those correct, you should pause the video, work through the examples, and see if you can find your mistake. Otherwise, let's move on to section 2. A Pythagorean triple. We've talked about this a little bit in class. It's a set of non-zero whole numbers that satisfy the equation of the Pythagorean theorem. So it is your a squared plus b squared equals c squared. So if that's true, then you have a Pythagorean triple. There are some common ones. If you can recognize them, it saves you some calculation time. So some common Pythagorean triples are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. So remember that in a right triangle, the longest side happens to be the hypotenuse across from the right angle. So if I have a right triangle that has a hypotenuse of 17 and one of the legs is 8, I automatically know the other leg is 15. We can get infinite number of sets of Pythagorean triples by multiplying by common terms, the same term for each side length. So if you multiply each number in a Pythagorean triple by the same whole number, it creates a whole new set of Pythagorean triples. So if I have the Pythagorean triple 3, 4, 5, it becomes 12, 16, and 20 when I multiply everything by 4. So if you can find factors in your Pythagorean triple that can work backwards, you can figure out what your side lengths are. For example, let's take a look at the next couple triangles. we are given a right triangle with side lengths 45, 24, and x. So x clearly has to be bigger than 45, and we can quickly look and see 24 and 45. So the factors of 45 are 3, 15, and 9. So I know that in my Pythagorean triple list, a medium term is 15. So I must have multiplied 15 by 3 to get 45. I can check to see if I multiplied 8 times 3 equals 24. That is true. So I know that this is x must be 17 times 3, which is 51. Sometimes this is helpful, sometimes if it's not. If you can't remember your Pythagorean triples, then you go back to your Pythagorean theorem and solve for x using that method. 30, 40. Those are factors with a multiple of 10. We have 3, 4. This must be 5 times 10, which is equal to 50. So you pause the video at this point and try the one below, see how you do, and then replay your video. Okay, you should have gotten x equals 15. Again, if this is not useful for you, don't use it. You should use your regular formula factoring those out, so don't worry about it. Let's do some finding distance or application problems. So in a dog agility course, it contains a seesaw obstacle. To the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel? So when we're parallel, we're going to end up here. That means we're parallel to the ground, which means we make a right triangle. This says 26 inches because it doesn't come out so well, and this says 36 inches. We know how to do this. We have a Pythagorean theorem that tells us 36 inches squared is equal to x squared plus 26 squared. X squared is equal to 620. When I work the math, I end up with x is equal to the square root of 620. Again, this is an application problem, so the square root of 620 doesn't tell me anything. So I should put it in my calculator and get approximately 25 inches. There is a practice problem below. You can pause your computer and go ahead and try that one, and then check your answer by starting play. Okay, as you can see, I actually sketched a figure so that it gave me a better idea of how I need to set up my equation, and you should find that your width is approximately 15.5 inches wide. If you did not find that, then go ahead and pause the video, look through the math, and find out what went wrong. Alrighty, last of the information. This may be new to some of us. We are dealing with classifying triangles. These are using converse. These are converse Pythagorean theorems. We are given some information about the triangle, and then we determine if it's a right triangle or not. Using this process, we can, in the process of using it, can also find out whether a triangle is acute or obtuse as well. These are the numbers in your book that tell you where you can find your theorems. But basically what we look at is if, since this is a converse, we go backwards. If a squared plus b squared, if the square of the legs, the sum of the square of the legs, is equal to the hypotenuse squared, then we know ABC is a right triangle. What if a squared plus b squared is less than c squared? Using the hinge theorem, if that's true, that makes the angle C smaller than 90, which means we have an acute triangle. So if I take two of the smallest sides, so remembering that we're looking for a right triangle, so this would be the largest side if it was a right triangle. So we want to look for the largest side being less than or greater than the sum of the squares. If a squared plus b squared, if two of the smallest and medium legs added together are greater than c squared, then we have an obtuse triangle. As I said, these theorems relate to the hinge theorem, which states that the longer side is opposite the larger angle, and the smaller side is opposite the smaller angle. We learned that last semester. Now again, remember, if the triangle is a right triangle, then the hypotenuse is the longest side in the triangle. So let's try some. Classify the triangle as right, acute, or obtuse. So we need to use the converse Pythagorean theorem because we're already given some measures. So when I start these, and if there is a radical in the problem, you are going to want to approximate that radical. So you can find out, make sure that this is, whether this is the longest length or not. So when I put this into my calculator, I'm going to make sure that I put 3 times rad 13 in parentheses before I square it. That way it will give me 3 times 3 times rad 13 times rad 13. Because that's going to be times, this says 3 times rad 13, and I'm doing that twice, so I end up with 3 times 3 is 9. Rad 13 times rad 13 is going to be times 13. Okay, so otherwise, if we don't put parentheses around it, your calculator is just going to square the 13, and you'll get an improper number. So if I set this up, 3 rad 13 squared, and I'm looking to see if it's less than, equal to, or greater than the sum of the other squares. C squared plus 9 squared. The reason I set this as my C is because my calculator tells me this is 117. So I know it's the longest side of the triangle. So now I got 117, 36 plus 81. 117 and 117. Those are equal values, so I know this must be a right triangle. Okay, let's do the next one. So I'm going to look and see 5, 4. This is going to be 2 times 2 times 10. Because when I take this radical through and square it, 2 times 2 times rad 10 times rad 10 is 2 times 2 times 10. 2 times 2 is 4 times 10, that's 40. So this is clearly the larger side. So I need to set up 40 and the square of the other 2 to see if it's greater than, less than. 40, and I get 41 when I take 25 plus 16. 40 is less than 41, so I know I have an acute triangle. Sometimes they will give you the side lengths in numbers without the visual. You may always draw the visual, or you can take a look and see which is the largest side. So I put rad 30 in my calculator. I get approximately 1.5. So rad 3 is not the hypotenuse. The longest side is 3, so I need to set it up as 3 squared, question mark, rad 3 squared plus 2 squared. 9, question, rad 3 times rad 3 is the square root of 9, which is just gets me back to 3. So when I square a radical, the stuff that comes under the radical is what comes out. Plus 4, 9 is greater than 7, so I have an obtuse triangle. Okay, you've got the next 3 to practice on your own. This will be the end of the lecture, so pause the video, try the problems, and then come back and check your answers. Okay, there's the answers for your practice problems. If you did not get them right, you should pause your video and look for your math mistakes. If it turns out that I got them wrong, then we can talk about it when you come to class tomorrow. You should be ready to rock and roll with practice problems, and I will see you in class.